Hello everyone, I'm Sagar Dhotare. Today we are discussing about the theory related to sliding contact bearing. Okay, so basically we have already seen the different type of rolling contact bearings, the application and the design. In this lecture, we will discuss about the different type of journal bearing. What is the journal bearing? How the different type of lubrication systems or how the lubrication is done in a journal bearing, and the comparison between rolling contact and sliding contact bearing. Basically, the bearing is nothing but a machine which can be used to support a rotating member via shaft, and they can transmit the load from rotating member to stationary member, which is known as a frame or housing. They permit a relative motion to the two members in one or two direction with minimum friction, and also prevent the motion in the direction of the applied load. Basically, we know that the classification of the bearing, which is under two categories, based on the contact contact point, sliding contact and rolling contact. The sliding contact bearing having surface contact and are coming under the kinematic pairs. Now, if we consider a kinematic pairs, so it having some advantages and disadvantages over the other type of bearings. So few advantages are, with respect to the design point of view, these bearings and the housing related to bearings are very simple in construction, as well as it can be easily designed. Then it occupies a very less radial space and it provides more impact. Third one, about the cost point of view, the sliding contact bearings having a very low cost as compared to the rolling contact. Then with respect to the design of shaft, as we discussed that as the design of bearing is very simple, so that uh, it it is very easy task to calculate the forces, dynamic or static forces which is applied over the shaft, and by using the uh, torsional, otherwise you can use bending formula or combined load condition, and you can easily design the shaft. Then about the operation, it operate silently when it start rotating. Then it having a good capacity, it can easily uh, absorb the shocks. They are ideally suitable for medium and high speed operation, but not for extra high speed. So similarly, it having some disadvantages. Those are the frictional power loss is very more, as at the starting it requires more torque or more power so that it can be uh, properly start rotating. And how we will discuss it with when we discussing about the hydrodynamic bearing. There you can clear this concept. Also, they required very good attention to the lubrication, as the name suggests, sliding contact bearing. So there is a metal to metal contact. Uh, because of that metal to metal contact, the friction is more, and the wear and tear is also more. So we have to provide particular attention on to maintain the fluid film in between these two contact surface. They are normally designed to carry a radial load or axial load only, because it can be very easy with respect to the sliding contact. They can suitable only for one directional. If there is a two directional load is applied or bidirectional load is applied, then there is a possibility of leakage, which can be very more very important and tedious task with respect to the sliding contact bearing. That's why uh, one directional, that is a radial or axial, only one directional load is always uh, applied over the sliding contact bearing. Then basic classification. Here I have considered three parameters. Based on that, the classification is done. First is based on the type of load carrying. Second one is based on the type of lubrication, and third one is based on lubrication mechanism. So in the bearing type of load carrying capacity type, there are three types: radial bearing, thrust bearing, or you can say axial bearing, and third one is a radial and thrust bearing. In the based on the type of lubrication, thick film lubrication, thin film lubrication, and boundary lubrication. And last one is based on the lubrication mechanism. That is a hydrodynamic bearing, then hydrostatic lubrication bearing, then elasto-hydrodynamic lubricated bearing, boundary lubricated bearing, and solid film lubricated bearing. So here we will discuss one by one. Radial lubricating bearing. So in a figure 1, you can easily find the concept of radial lubricated bearing. In the radial lubricated bearing, the shaft is directly connected with the directly mounted or inserted inside the hole. Okay, where it is directly mounted over the we can say over the journal. Okay, so in this case, there is no radial there is no such outer and inner racing or cages. Only one metal surface, or you can say a journal, is a part that can be inserted inside the hole, and on that the shaft is directly mounted. Okay, so here the radial bearing we can consider because it rotates only in one direction and it carrying a load only from radial direction. Now in a second figure, figure number 2, we can see that the force applied is towards the axis or parallel to the axis. So you can say this type of bearing is thrust bearing, or you can say it's a radial bearing. If you look at the picture, the whole load is applied in this region. Okay, so in this case, in a radial, load is applied point at this point where the metal to metal contact is occurred due to radial load or self load also. And in this axial load cases, the force is applied axially, and which is the pressure or you can say contact area, which is shown over there, and this contact area directly used for wear purpose, or you can say this area is considered for design purpose. Now next one, the radial thrust bearing. In the radial thrust bearing, both axial as well as radial loads can be carried. You can look at the figure number 4 where the arrangement is shown. Next one, this is depend upon classification is based on the type of lubrication. Now here there are 3 type of lubrication which we normally use, that is a thick film lubrication, thin film lubrication, and boundary lubrication. So figure number 1, or you can say figure number 5, by mistakenly it is noted as figure number 1. The surface is separated by a thick film of lubricant and there will be no metal to metal contact. The thick film is about to 8 to 20 micrometer. Typically, the value of coefficient of friction is in between 0.002 to 0.01, and hydrodynamic lubrication is coming under this category. Here the wear is very minimum in this as compared to the remaining cases. The wear is very less. Normally we are using a grease as a lubricant in between this thick film lubrication. Next one is a thin film. In figure number 6, the thin film lubrication, the idea or cross section is given, so you can directly get the idea. Here, even though surfaces are separated because of the thin film of lubricant, but there is a metal to metal contact at the high spot. Means whatever the valleys are generated or crusts are generated, which is in directly metal to metal contact exists. Otherwise, there is no contact between other total surface, which is occurred in a boundary lubrication. The normally it is called as a mixed lubrication. If you look at the diagram, figure number 8, just a minute. In figure number 8, we have drawn the coefficient of friction versus sliding velocity. Now here, if they look at the three regions, first one is a boundary friction, second one is a mixed friction, and third one is a elasto-hydrodynamic friction. So in these regions are occurred based on the surface area and based on the sliding velocity, or you can say rotating speed. If the rotated speed is a high, then the metal to metal contact is get directly avoided. If the speed is medium, then in this condition the friction or depend upon the viscosity of the lubricant, the mixed type of friction will be increases. But in case of very low speed, the boundary lubrication is directly come into the picture, where the surface to surface contact is occurred, and it is very extensive because the both surfaces are directly come in contact with each other. And here at the starting condition or at the end condition, the friction and wear is more because of there is a very, or you can say a very thin film in between these two sliding surfaces. Typically the film coefficient of friction is 0.05 to 0.07. As in shown, you can also find the graphical representation based on these regions. When we consider a boundary lubrication, this coefficient is normally depend upon the oiliness of lubricant, then surface finish of the containing surface, and the material of the containing surface. So based on these parameters, this boundary lubrication is dependent. Again, because of the directly surface, or you can say the highest point are in contact, there is a possibility that the interlocking will be happen in the asperities that can that take place where the metal to metal contact is going to happen. The gross seizing is prevented, or which is the gross seizing is prevented. The coating of the lubricant or the contact surface, and because of this reason it is called as a thin film, or you can say a boundary lubrication. Now in this condition, the heavy load or low viscosity of lubricant or insufficient supply of lubricants lead to such kind of lubrication process. Even hydrodynamic bearing possesses through this type of boundary lubrication region at the beginning of the operation and also at the end of the operation. So these three regions are very important while discussing, or you can say while selecting the bearing or operation. First one is a boundary, or you can say thin film. Second one is a mixed one, and third one is a hydrodynamic lubrication, or you can say here it is shown as a hydrodynamic. Third one is provided over here. Now in a mixed film, or you can say mixed condition. So in this mixed condition, the region is in between, the contact surface is greater, but the completely high pressure oil film separated by using two surfaces which is not properly not formed, and because of that the localized area or patches of the fluid film, these are covered the entire surface, and because of this few crests are in a contact, and because of that most of the part which is not in contact in between in two surfaces, or you can say shaft and journal. In this condition or mixed condition, only crest points or higher points or peak points which are in contact with each other. Okay, so here the oil film will be maintained in the other area, and directly metal to metal contact will be occurred in the peak area. So that's why it is called as a mix type of lubrication. Next one, that is a thick film, which we have already discussed. There are a few parameters. Based on this, the thick films are normally dependent. That is a bearing modulus and the Mackey's equation, okay, which we'll discuss in the next part, where we are discussing about the non-unitless parameter, okay. Next one, the basic classification of based on the lubrication mechanism. First one is a hydrodynamic lubrication. Second one is a hydrostatic lubrication. Hydrostatic lubrication. Third one is a elasto-hydrodynamic lubrication. Next one is a boundary lubricated bearings, and last one is a solid frame bearing. In a hydrodynamic lubrication, the two surfaces in a relative motion are separated by a relatively thick film of fluid, so that to prevent the metal to metal contact, and it can be this separation in between two surfaces occur due to the hydrodynamic action of the fluid. So that's why it is called as a thick film lubrication or hydrodynamic lubrication. So there are a few steps based on this process can be occurred, and it is occurred. Next one is a hydrostatic lubrication. In the hydrostatic lubrication, we are provide pressurized fluid externally by using pump, so that it can be automatically get or it can be automatically get in the central position of the shaft with irrespect to the speed. तो इसमें क्या होता है कि अगर स्पीड कम ज्यादा भी हुआ तो उसका शाफ्ट के इसेंट्रिसिटी पे कोई भी इफेक्ट नहीं होता. बट इन हाइड्रोडायनामिक it can be affected by the speed. In elastohydrodynamic lubrication, which can be occur when the lubricant is introduced in between the surface which are in rolling contact, such as a mitting gear, which is as shown, then rolling elements or race of rolling contact bearings, or you can say cam and follower, where the elastohydrodynamic type of lubrication is occurred. Then solid lubrication, solid film lubrication. In a solid film lubrication, when the bearings are operated at extreme high temperature, the lubricating oil are not suitable at that condition and they can lose their properties. Okay, so yes, if you are working with a high temperature, as we know that as the temperature increases, the viscosity get decreases. So in this condition or such condition, we are using solid lubricants such as a graphite or molybdens or uh, disulfide. So such type of the solid lubricants we are normally use for this extremely high temperature condition. So based on this type of lubricants we are using, the different or classification is done. Next one, we will discuss about the journal bearing. So there are three types: full, partial, and fitted. So in our design aspect, we will design full, partial, as well as fitted. So partial, it may be 180 degree or 120 degree. Full, obviously it is 360 degree, or fitted, which is generally about 120 degree. Now these are it can be called as a journal or sleeve. Okay, the radial bearing also called as a journal or sleeve, but depend, if you are not using any rolling element, then it is called as a journal bearing. Okay, the portion of the shaft inside the bearing is called as a journal, and this portion needs to better finish and specific property. So which is used, that is I have also told you that the there is no rolling contact in between the surface and hole. There is only one sleeve is provided. It's similar that the liner is provided inside the cylinder block and the piston is moving in between that. So similarly here, the liner, the what you can say, the position or जो liner है, which can be replaced by sleeves. And if in that condition in IC engine, that the reciprocating motion is occurred, rather than this here the rotary motion or a radial rotation, rather than this rotary motion is occurred. Okay, so or load carrying capacity, or with respect to the load point of view, only radial load is considered. Depending upon the extended to which the bearing develops a journal, these bearings are classified as a full, partial, and fitted bearing, which is shown previously. Now next one is a hydrodynamic bearing. When the bearing is supplied with adequate oil, the pressure is developed in the clearance space when the journal rotates about an axis that is eccentric with the bearing axis. It at initial condition it is eccentrically mounted, because at this condition is called as a rest condition. In this condition, the journal shaft is directly mounted on over the journal, and the metal to metal contact is occurred. So here and the fluid film in between these two at this condition is very thin film is in between these two surfaces. The load carrying ability of hydrodynamic bearing arises simply because of viscous fluid resist being pushed around under the proper condition. This resistance to moving with the develop a pressure distribution in the film that can be supplied useful load. Two mechanisms responsible for this are wedged film and squeeze film action. The load supporting pressure in a hydrodynamic journal bearings arises from following two factors: the flow of viscous fluid in a converging channel or wedge film, or the second one is the resistance of viscous fluid to being squeezed out from the between approaching surfaces, that is called the squeeze film. In a simple manner, we can say we will discuss with this number of with different stages. So first stage we can consider as a resting condition where there is no speed is applied, directly metal to metal contact is there. Okay, so look at here, the shaft is directly mounted over the journal and metal to metal contact is existed. Okay, you can say shaft and bearing, or you can say journal and bearing. So जर्नल को ही हम लोग इन हाइड्रोडायनेमिक बेरिंग की कंडीशन में शाफ्ट कहते हैं. सो नॉर्मली यू कैन से जर्नल और बेरिंग और शाफ्ट और बेरिंग. ओके, सो हियर the journal is mounted over the bearing. The bearing is created with the help of sleeve. Okay, so don't confuse in between sliding contact and rolling contact. The structure, or you can say the mounting are totally different in both bearings. Okay, so at the rest condition, the bearing clearance space is filled with the oil, but the clearance in between the two meeting surface is very low because there is a metal to metal contact. If we apply some force on that journal or shaft, because of that pressure, the whatever the film thickness is created in between journal and bearing, that is directly squeezed out because of that force, applied force. And because due to that, the metal to metal, or you can say direct metal to metal contact is created. If we applied a rotation, or you can say when we start rotating machine, then we are going towards the stage number 2. So here we have started the rotating journal slowly in the clockwise direction. Because of friction, the journal starts climbing the wall, the bearing surface, which is as shown in figure number 14. The boundary lubrication is existing over here, and because of the wear normally takes place in this condition at the region where the metal to metal contact is occurred, the general rotation draws the oil film between the surface and this separates. In this condition, or this is the second stage where actually journal try to clamp over the layers of fluid film. Okay, तो यहाँ पे कैसे होता है कि शाफ्ट ट्राई करता है रोटेशन के लिए. तो इनिशियली बेरिंग और शाफ्ट दोनों का मेटल टू मेटल कांटेक्ट रहता है. And because of that metal to metal contact, shaft is try to climb over the journal. Shaft is, or journal is try to climb over the bearing, or because of that the pressure is created in the oil, that is called as a hydrodynamic action. And because of this hydrodynamic action, the layered because journal is trying to climb the layers, so जैसे ये climbing start हो जाता है और pressure develop होता है, because of that both action, the clearance in between journal and bearing get increases and the shaft get lifted. Okay, and it separates in between, it properly separate because of the oil. Then stage number 3, as the speed increases, more oil is drawn or move in between these two journal and bearing, and enough pressure should be built up. If the pressure reduces, automatically the metal to metal contact will be gained. Further increase in speed, the additional pressure of converging oil flow to the region of minimum film thickness portion, that is denoted by HO, moves the shaft slightly towards the left of the center, okay, which is not at a constant position. As a result of full separation of the journal and the bearing surface, which can be occurred over here. In the stability operation condition, it means that the operating in a continuous manner. At that condition, the bearing pressure distribution in the journal, which is shown in figure number 16, and this called this action, or you can say because of this जो भी shaft lift हुआ है and in between the surface or minimum oil film thickness generate हुआ है, this condition or this kind of action we are called as a hydrodynamic lubrication, or you can say thick film lubrication. Normally it can be occur only because of the sufficient speed as well as enough pressure which is developed because of the rotation. Okay, so this is the basic condition, or you can say basic criteria with respect to the hydrodynamic lubrication or hydrodynamic bearing. अगर आपको metal to metal contact नहीं चाहिए तो enough speed चाहिए. Because of that, the oil pressure can be generated properly and the separation of the bearing and journal could be occurred. Now next one, we need to understand few advantages of hydrodynamic bearing. Because if these are simple in construction and very easy to maintain, we have to apply oil, or you can say directly we can use grease in between the journal and bearing, so that we couldn't maintain, or you can say हम लोगों को ज़्यादा उस पे ध्यान भी नहीं देना पड़ता. As we are using grease example, the maintenance is very low and initial cost of this kind of bearings are also very low. It doesn't require any external equipments like a pump or filters. Also, it having a low power loss, as it directly increase at initial condition the friction is very high. That is a big disadvantage of the hydrodynamic bearing. We cannot use such kind of bearings for low speed application as well as extremely high speed application. As we saw, because of at low speed the frictional losses are very high, then it required very high starting torque, or you can say high starting friction, then poor positional accuracy, because we have already seen that as the speed increases, the pressure, because of the pressure and the input oil venturi, or you can say because of that position, as the pressure drops, the eccentricity get varied. मतलब जैसे स्पीड इसका चेंज होता है वैसे ऑयल प्रेशर उसका चेंज हो जाता है, एंड बिकॉज ऑफ दैट द इसेंट्री ऑलवेज चेंजेस. तो ये हमेशा कभी भी सेंटर पे नहीं रहता, ये हमेशा टुवर्ड्स द लेफ्ट ही रहता है, शाफ्ट सेंट्रल पोजीशन. Not suitable for where we are using frequently starting and stopping the machine. Then Then the basic application where we can use the hydrodynamic bearing. If for engines, we are using hydrodynamic bearings, then large centrifugal pumps, then hydraulic turbines, and guideways of machine tools. We have already worked with the lathe machine and milling machine where the guideways are used. That in that condition or in that way, we are called as a hydrodynamically uh, bearing. Hydrodynamic bearing are mostly used in this way. Next one is a hydrostatic bearing. So hydrostatic bearing are very simple in construction, similar to hydrodynamic, but in this case, uh, these bearings are already uh, supported by high pressure fluid, and it creates the difference, or you can say clearance, in between journal and bearing, okay, and which is constant because we are applying continuous high pressure oil. The lubricant which is pressurized externally and supplied in between two surfaces so that the bearings do not require the motion of one surface relative to another, which is, we can say, hydrodynamic action, which is not required in this case. So few advantages of hydrostatic bearing. They are able to take a very heavy load with low speed. Load carrying capacity of the bearing which is not dependent on the speed variation. Low friction losses at starting condition. High positional accuracy because we are applying external pressure, so it is continuously having same position. And then external lubrication is not required. Disadvantages: it required auxiliary equipments like pump, filter, oil. Then because of that, these auxiliary equipments, it is very complicated structure and very expensive. High initial cost as these equipments and the skilled worker are required for manufacturing, or you can say very high precise manufacturing is there, so that's why the initial cost is very high, and there are a number of dependent components are there, so that's why the maintenance is very difficult as well as costly. Basic applications where the hydrostatic bearings are used. First one is a hydraulically turbine generators, sorry, vertical turbine turbo generators, large telescope, machine tools, then rocket engines, gyroscope, high-speed dental drills, rolling mills, and food packaging machinery. So basic comparison in between rolling contact and sliding contact. In examination, they are mostly asked about the difference between sliding and rolling contact based on the parameters. So here few parameters we have considered. First one is a speed. In a journal bearing, or you can say sliding contact bearing, which can be efficiently operated at high or medium speed. But in a rolling contact, it can be efficiently operated start with a low speed. About the friction, the power loss due to the friction increases at high speed, which requires proper oil flow rate and to reduce the heat generated. But in rolling contact bearing, the low friction in a lower speed, but high friction in a high speed. About the maintenance point of view, journal bearing requires very low maintenance, and we need not to worried about the maintenance. But in a rolling contact, yes, occasionally we need to maintain properly. About the shocks, uh, journal bearing bears the shocks and high loads, but in a rolling contact, it doesn't withstand with the shock and high loads. About the axial length, journal bearing very long to bear the shocks and high loads, in an axial because of that axial length, and about because of to maintain or to absorb these shocks, the length of or you can say dimension in axial are very high as compared to the roller. Roller bearing requires very less space, and the length axial length is relatively less. Bearing life, it having a long life. About the roller, it have a shorter life. Failure conditions. Journal bearing, lower possibility of failure occurs. In a rolling contact bearing, there is a high possibility for failure occurs. About the application, the high-speed applications like turbines and compressors, we are using sliding contact bearing. Where the low and rolling contact bearings, where the gearbox, where the variation in speed can be used. Okay, so this is a basic difference between sliding contact and rolling contact bearing. So today okay, thank you very much. So today we have discussed that much theory. In the next lecture, we will discuss about the various parameters and the which is dependent. For example, what are the different design parameter which we can use, or variable parameters which can be we can change. Based on that, the sliding contact bearings design can be occur. Also, we have to discuss about the uh, different nomenclatures, then Petrov's equation, then dimensionless parameters, which can plays a very important role for the design aspect or design point of view. Okay, so thank you very much for joining me. I will end this meeting now.